Right, for those of you listening at home, we're working through a few of the problems through the homework, and you're going to do the ones under them. Sorry, here we go. All right, so if you divide the square root function in Euclid to numbers that square root nicely, that's where we go. Now, underneath in B, it says, estimate the area using 5 left-hand rectangles of unequal. We got the unequal subdivisions done. Well, let's talk left-hand. So from 0 to 1. Where do I draw the height, Cole? At 0 or 1 if I'm using left hand? Left hand. 0, okay? So 0 to 1, I'm going to use the height at 1 or 0, which means unfortunately I'm not going to really get a very tall rectangle. You with me? From 1 to 4, if I'm using left hand, do I draw the height at 1 or 4, Marcus? 1. All right, now when I say draw the height at 1, this is what I mean. Start at an x of 1, go up to the curve, and we're using that for the height of the rectangle on the right-hand side, from 1 to 4, yeah? So the rectangle from 1 to 4 will have that height at that level of 1. You with me? All right, from 4 to 9, do I draw at 4 or 9, Bailey? 4. 4. And so if I draw at 4, I go up to the curve and draw over to 9, making that my rectangle. Harrison, from 9 to 16, use 9 or 9 or 16. 9. And at 16 to 25, I use 16. Am I going to get an overestimate or an underestimate, really? An underestimate. Certainly I'm going to get an underestimate. All right. Now, okay, so you're going to do C on your own. So this is what I want the work to look like then when we go to put our answer together. This I'm going to gradually do less and less of. That's optional. The idea of, hey, person reading this, I'm using 5 rectangles. You don't have to show that every time. I'm just, the first couple days I tend to write that to remind you you're finding the area rectangles. The key first step really needs to be this kind of thing. The base is delta x1, f at x1, delta x1, f at x1, plus delta x2, f at x2, through delta x5, f at some 5th month. You follow? All right, now under those, normally I would, let yourself a note, normally I would factor out delta x, but that's when that delta x is equal. It's a common factor. These aren't common factors, so that's only if it's equal subdivisions. In this case, they're not equal, so that factoring a delta, that's out. I can't do it. All right? So now I need to figure out each one. What is the first delta x? Actually, let's go and doctor up our picture. I find it easier to do that. The first delta x is 1. The next is 3, 5, 7, and 9. Did you ever see that before? Did you notice that the difference between squares is an odd number pattern? Pretty cool. 1, 3, 5, 7, 9. Okay, so that said, the first delta is 1, and I'm going to communicate, rather than go straight to the value, I'm going to communicate the first height is using f at 0. Perfect, all right? The next rectangle will be a delta of 3 and f at 1. The third rectangle is a delta of 5 and f at 4. The fourth rectangle is a delta of 7 and f at 9. And the last, 9 f at 16. You see where we're from? Okay. After that, it's these are really the two things I would need to see. After that, however quick you do the arithmetic is up to you. If your mind works quick with arithmetic and you can say, what is f at 0 and multiply at the same time, fine. Me, I'm a little slow-witted, so I'm going to go slow. So I'm going to go 1 times 0 plus 3 times 1 square rooted is 1. 5 times 4 square rooted is 2. 7 times 9 square rooted is 3. And 9 times 16 square rooted is 4. Each of those products is 0 plus 3 plus 10 plus 21 plus 36. And now totaling that up, what I got you, 13, 34, I'm feeling 60. Correct me if you disagree. Okay, now don't worry about units. I know it's what you being taught well at the school. Are you sure?
Yeah.
I said you're taught well. Me, I wasn't taught so well because I can't add. 70. You don't need to worry about units. Right? We're going to talk to you about units later. 70. All right, with me? All right, with that said, I think you should be able to do the same kind of idea but right hand. You don't need to redraw it. You can use your previous picture. What will be the same? What will be different when you do right hand? Yeah, delta x will be the same. The heights will be different. Right?
Yeah.
All right, so you should be able to do that this weekend. I know you want to do it now, but don't. Let's move on. Okay? Let's go on to a table of unequal subdivisions. That'll be your homework. You can do C for home. All right. Go to number 2, and let's get you started here. If I sketch the region, it doesn't have to be pretty. It doesn't take a lot of time to do this pretty well. I think you'll agree that in X I need to go out to about 20. 20. Actually, maybe I should show those. That's just going to confuse me. Okay, so let me place down my numbers. I have an X of 2, 11, and 19, and 20. Really, it's better if you don't put any scale down. If you just show the numbers of the x's in the table only, right? Because otherwise you can confuse yourself on your delta x's. You with me so far? For the heights, I need to go up to 10, so I need to basically graph 0, 3, 2, 2, 11, 10, that's high, 19, 4, and 3. So, something like, I think it's tempting to play connect the dots, but you really have no idea what the curve looks like, so that would be foolish. All right, way down. Okay, so cool. Would you show delta x's above the table, please? This will make it easier in the graph, all right? Or maybe in graph. So, for example, what's the first delta x? 2, okay? And doesn't that make sense here that that rectangle is 2? The next delta x is 9. The next is 8. And finally, 1, all right? So when I go to do 4 left-hand rectangles, my area will be approximated by delta x1, f at x1, h, yes, read carefully, it's not f here, it's h. Delta x1, h at x1. Delta x2, h at x2. Delta x3, h at x3. Delta x4, h at x4. Are you with me, my friends? Whatever. You want to call it students. Right? So here we go. Bailey, delta x1, what is it? 2. And the first height, because I'm using left hand, Andrew, will I use h at 0 or h at 2? H at 0. Perfect. Okay. Colin, what's delta x2? 9. And the next height, Miss Brown, is height between 2 and 11. Do I use height at 2 or height at 11? Height at 2. All right, Alex, what's delta x3? 8, I agree. And Campbell, what height do I use for height 3? Do I use height at 11 or height at 19? 11, yes, the left-hand side. Emily, what's delta x4? 1. And the last is height at, Brian, what's the height, the last, height at 19 or 20? 19. Do we ever use height 20 in this? Not for left hand. What would we use it for right hand? Yes, okay. So after that, it's going to the table 2 times h at 0 is 3. 9 times h at 2 is 2. 8 times h at 11 is 10. And 1 times h at 19 is 4. So I am something like 6 plus 18 plus 80 plus 4. Did I make a mistake? Okay. 24, 104, 108. We good? Okie dokie. Are you tracking here? Could you do right hand on your own for homework?
Oh, yeah.
Cool. Let's jump to the next idea. All right. For number 3, do you see, is it clear where I'm at? It's still on the front page. Okay, cool. Would you draw me a first quadrant function that has a y-intercept above the origin and is increasing, something like that, right? And then make an exact copy of it next to that. And I'll explain why. Okay? 2, increasing first quadrant, y-intercept positive graphs. Follow? Okay. So it's often the case that not only do you estimate, but then they said, all right, is this an overestimate or an underestimate? And in the AP test especially, they want you to say it really well. All right. Now that's what this is getting towards, not only what's the concept, but how to say it really well. If I were estimating the area under that curve and I used a left-hand rectangle, then between, let's just make an endpoint, will you? And between 0 and that point, if I use left hand, then I would use this height and draw this way, and that's what left hand would look like. You follow? And if I then, on the second one, instead I use right hand, then I'd go to the right edge, draw up to the curve and over, and that's a right hand. You with me? All right, notice that when drawing rectangles, if the function is increasing, then the left side has to be less than the right side because it's increasing. And therefore, if you use the left side for the area, then you're going to get a y function that's way less than most of the points on the curve, and you will get an underestimate. All right, so left-hand rectangles underestimate. When do they underestimate? Well, when the curve is increasing. If you use a left, now it's not just one or just the other. It's the combination of left hand and increasing together that makes for an underestimate. Follow? Likewise, it's the combination of right hand with increasing that makes for an overestimate. So if on the AP test they asked, is this an over or underestimate? You wouldn't say, hey, well, man, look at my picture. The rectangles are above the curve. They don't look at your picture. I mean, the pictures are only for your benefit. It has to be said something like, this is an overestimate because I used right-hand rectangles on an increasing function. They have to make reference to those 3 things: overestimate, right-hand, increasing. All 3 of those need to be there, right? Likewise, underestimate and so on. You can do the next part. It's very intuitive and much like that. All right, go to 5. People have a hard time getting started with this last year, so I'm just going to get you a good picture and get you started. We're not going to carry this all the way through. You'll be good. Would you draw a fourth of a sinusoid? Now, by that I mean a sine curve, but only from 0 to pi over 2. So the part of the curve that goes from the origin up to the peak. And that's all I want to see. All right, now we're going to find the area under that curve. And we're going to do it with rectangles, but we're not going to divide it equally into 4 parts, because if I divide pi over 2 into 4 equal parts, what's each base? Yeah, so what's each 4 equal parts of pi over 2? Pi over 8. Now, do you want to do sine pi over 8? Immediately, okay? That's half angle identities. We don't want to go there, do we? Or do we? Actually, it might be kind of fun. Half angle identities? No. All right. So instead, we're going to use cleaner points that are reference angles. So what are the reference angles between? Pi over 6, pi over 3, and pi over 4. Now, in terms of where to put those, are those equally subdivided? Let's think of these as pi over 12. So pi over 6 is 2 pi over 12s, yeah? And then pi over 4 is next, and that's 3 pi over 12s. And pi over 3 is 4 pi over 12s. So it feels like unequal, and then 5 pi over 12s we're not using, and then 6 pi over 12s is pi over 2, right? So we're getting very unequal bases, 2 really partial bases. You follow? All right. So if I draw out right-hand rectangles, would you just real quick pencil in your rectangles? So I get 2 wide rectangles on the outsides and 2 thin ones on the inside. Yeah? So is this a case where I can factor out a delta x? What are the cases where you do have a delta x up front? What? Equal subdivision. Okay, so there's not a equal subdivision. This is called f. So I'm going to call my basics delta x1, f of x1 through dot, 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 delta x4, f of x4. You follow? I am definitely okay with you doing that dot, dot, dot stuff, especially if I said 12 rectangles, that's just too. All right. Yes?
But, so, we're not going to be using like that rotation, like a rectangle.
You'll be using, yes. Yes.
Like if you could you do like dot, dot, dot?
Yeah, they would be fine with that, yeah. Yeah, they wouldn't actually, I don't even know if they would have a point built in for that. Their first point would be built in for this next step. Calculates delta, shows f at which values. So what is delta x in the first case? Pi over 6, or if you like, 2 pi over 12. And the first height is f at pi over 6, okay? The next delta x, what's delta x now? It's from 2 pi over 12 to 3 pi over 12, that's a gap of pi over 12, and its height at pi over 4, yeah? And then your third delta x is from 3 pi over 12 to 4 pi over 12, so that's pi over 12, and f at 3, gotcha, and the last delta? Pi over 6, or 2 pi over 12s if you like, and f at pi over 2. After that, I just want you to calculate the sine functions. On the AP test, you are expected to be able to evaluate trigs. So, for example, when you have to do f at pi over 6, that means sine of pi over 6, which is 1/2. After that, I think you'll agree you're going to get some uglies, root 2 over 2s and root 3 over 2s and stuff. You can stop there. It says no calculator. I just want you to go that far and call it good. You with me? All right. That should get you going there. Next thing I want you to jump to is the last page, which is 8. I think this is the last page, problem number 8. All right. We talked a little bit about how area under the curve is not some just meaningless endeavor. There's meaning to it. This page is meant to give you a little feel for what's the meaning, what's the point of it all. The velocity of a car over a time interval is modeled by the equation v equals 1/5 t cubed from 0 to 5. Seems logical. I mean, you're at a stop sign. At that time, your velocity is 0, and then your velocity is not automatically 5 meters per second. You accelerate, you gradually increases, right? So this is actually a lot more like real life than all the algebra and physics you've done beforehand, which assumes uniform motion. That's not how life works. You don't always go 30 miles per hour. It changes. So in this case, then, I want you to sketch the curve in a wide fashion. Means this curve is most beneficial when it's really wide, so your rectangles communicate something. It should say scale of 1 for t, not x. That's a typo. Sorry about that. And t is on the horizontal. Go by ones. 1, 2, 3, 4, 5, and that's time in seconds. And velocity, what's the maximum velocity over the time interval? 25. 5 cubed is 125. Over 5 is 25. So if you go by 5s, 5, 10, 15, 5, and that's velocity in meters per second. All right, so we're going to graph this velocity curve. We'll just find the whole number. So velocity at 0 is 0. Velocity at 1, 1/5, so that's practically just barely above the axis, just almost right on the axis. What about velocity at 2? 8/5, so that's just barely above 1, between 1 and 2, still pretty small. Velocity at 3? 27/5, so roughly 5-ish, you know what I mean? Velocity at 4, 4 cubed over 5. 64/5 is 12 and 4/5, so almost 13. So about here. And velocity at 5 is 25. All right. That makes sense. We know a cube graph looks like this, but the 1/5 is causing it to be wide. And I am just taking a piece of this. So this graph seems like a logical piece of our cube graph. You with me? All right, this one I can feel confident in connecting the dots. It does look like that because I have the equation. I know what it's supposed to be. All right. Now, if in B they say estimate the area using 4 right-hand rectangles of equal subdivisions that include units in your work. I'll come to that in a second. So in the first subinterval, if it's right hand, where do I draw? At 0 or 1? 1. And from 1 to 2, where do I draw? 2. And from 2 to 3, I use 3. And from 3 to 4, I use 4. And from 4 to 5, I use 5. Am I going to get an overestimate or an underestimate?
Overestimate.
I'm going to get an overestimate because I'm using
Right hand
rectangles on a
increasing
function. All right. Now then, we're going to, this is equal subdivisions, so you would be 100% justified in factoring out the delta. It's not delta x here, though, it's delta t, yeah? I don't want you to factor it out, and I'll explain why. I'm just going to say the area is approximately delta t 1 v at t1 plus through delta t5 v at t4, sorry, right? 4 subintervals. I know we went to 5, but it's 4 gaps. Yeah, you with me? Oh, what the freaking heck?
It says 5.
Oh, I corrected it last year. Okay. 4 is disastrous because I don't want to go. Yeah, that sucks. Okay, so 5. We're good? So we do need to go through 5. All right, my bad. Okay. Good thing I fixed that. All right, now then, delta T1. Delta T1 is 1. Now with units, that's 1 second. And V at T1 is V at 1. Okay? Then it's 1 second V at 2. And then 1 second V at 3. And then 1 second V at 4, and then 1 second V at 5. You follow? Okay, all right. So now here's the goal. 1 second. V of 1. What's V of 1 with units? 1/5 meters per second. Then 1 second times what's V at 2? 8/5 meters per second. Then 1 second times what's V at 3? 27/5 meters per second. Then 1 second times what's V at 4? 64/5 meters per second. Oui. And then 1 second times V at 5 is, I know it's 25, but I'm going to go 125/5 meters per second. All right, cool. Now let's calculate. So the first is 1/5. What are the units? Seconds go, and it's meters. Pause for a second. What the heck did I just find? 1/5 meters. What is it? Yeah, it's distance and displacement because it's going forward. It's both the same. When I say 1/5, that really is saying I know the velocity is actually changing the whole time. But pretend I just said, you know what? Let's just say for that 1 second, I'm going to use a velocity, what is at time 1. So as an estimate of how far he went in the first second, he went about 1/5 of a meter in that first second. You follow?
Follow.
All right. In the next second, he was going a little faster, and I have lots of different velocities, but I'm going to use an overestimate. I'm going to say, what if his velocity was 8/5 for the whole time? Well, then in that second time interval, it would go 8/5 meters. And in the third second, he would go 27/5 meters. And in the fourth second, he would go 64/5 meters, and in the last second he would go 25/5 meters. Altogether then, how many fifths do I have? That's your 9, 36, 100, 225 is what I'm getting? 225/5 meters, which is 45 meters. That means over that 5 second interval, he traveled about 45 meters. Now that's pretty stinking incredible considering that his velocity was constantly changing. That we were able to figure out or give an estimate of how far he went. Each rectangle approximates, would you put displacement? Because technically it's displacement. If it was negative, I'd have a different issue. On a 1 second interval. These are approximations because, why are they approximations? Why isn't it exactly 45?
You overestimated.
Because what?
You overestimated.
Yeah. Why am I, did he really go 1/5 of a meter per second for that whole second?
No, you accelerate.
It's constantly changing, okay? So these are approximations because the velocity is not the same for the whole second. We're picking a velocity to use for that 1 second interval, but it's really not the same for the whole time. And so because of that, I'm getting an overestimate. I'm using the highest possible velocity in each 1 second interval. All right. Now, this is great, but it doesn't have to be, if you're a non-physicsy person, this is still totally applicable. Every day when I am in the front hallway, and I see, or actually this hallway, and I see people coming at a variable rate, when I see people coming at 7-ish, 15, it gets really intense about 7:15 and then stays there until about 7:30 and it totally drops off, yeah? Now, if this is the rate at which people come in every minute, then when I take that rate and multiply it by a number of minutes, what's that area? How many people came in that minute? And then in the next even though it's a totally different rate, I can say, well, now they're only coming in about 2 people per minute, for a minute. That area is a totally different number of people. So that the area under the curve would estimate how many people came in. All right, now, would you write yourself a huge note? Area under a rate of change gives amount of change. For example, area under the rate of change in position, velocity, gives you amount of change in position, a change in position. Yeah. All right, so with that said, let me explain what I want to see here. In number 9, I'm giving you a rate, not a velocity necessarily, just some kind of rate. What would the area under the curve represent? Include units and refer to the time interval in your answer to start preparing for AP questions. So I'm saying something like this. When you do the area under this curve, population curve, okay, the population of a town changes at a rate of P, exponential growth, which is common for population growth, for time 0 to 10 seconds, where P is people per year and time is in years. Now, you don't need to have a picture necessarily, but when you find the area under the curve, think units. It's the area is P times delta T. The units for P are, what does it say at the back end? People per year. And the units for time are years. When you calculate the area under the curve, base times heights, which are populations times delta t's, you're getting people. People what? What kind of people? What's people more specific? People what?
People being born.
People being born. Actually, and is that the only way a population changes?
No.
There's actually 2 reasons, 3 reasons of population, 4 reasons of population change. What are they?
Immigration, emigration, death, life.
Beautiful. Well done. Immigration, emigration, death, and life. Birth and death. All right. Now, this is a net rate. So, we would say that the area is the change in population from time 0 to time 10, time 10 years. Follow? Okay. Try one on your own. Try B. So what do you think? The area represents change in, so you could either say this one of 2 ways, the change in the number of students, or you could just say how many students have entered. Okay, area is the number of students who entered, which is the change if you consider that it's only about entering, who entered from when to when. Time equals 7 hours to time equal 9 hours. Any time in an explanation you offer a number, you should offer units with it. Okay? You follow me? From time equal 7 hours. Sorry, now I know where you're at. Looking at 7 hours. With me? Have it. Okay, cool. Good deal. You should be good on the rest. All right, the rest of them are yours. I think you'll be fine. That was review, so you should be cool. Questions on last night's homework? Set 90, 80, 70?
14.
30. 39,
14,
14,
22,
22,
3,
3. Rapid fire, that's the guy that knows how to get his questions answered. All right. 14. All right. So 14. Oops, I almost wrote on the board. 14. Would you? They say you've got the log function, and they're asking you to make some kind of function for the slope between these. So if you say the slope is f at x minus f at 2 over x minus 2, or better, natural log x minus natural log 2 over x minus 2, that's what they want you to put in your calculator. So would you get out your calculator? Put natural log of x minus natural log of 2 over x minus 2 in your calculator. Make sure you use parentheses well to enclose the entire numerator and the entire denominator. And when you go to see this, please don't expect to see a log graph. When you're not graphing log, you're graphing this kind of slope calculation, right? So if it doesn't look like log, that's good. It's not supposed to. Are you with me so far? Or should I give you a second? Okay, so the idea now is, all right, great. I want you to trace x close to 2. That basically means if I said x close to 2, then I'm looking at the slope now, and the slope here, and the slope here. What happens as this point x gets closer and closer to 2? Well, the slope between 2 points approaches the slope at 1 point, which means we're trying to find the derivative, all right? So if you hit trace, to review the calculator functions, go to Menu, Trace, and Graph Trace, and just go side-to-side arrows towards 2. Now you can see that it depends on each calculator, my trace is going by 0.3 each time. I have no idea why that is, but it's going by 0.3 each time. If you don't like that, or if it's too big, then you can go back to trace and change your trace step to more like 0.1 or something smaller, 0.05, whatever. And so that when you trace, it's going to go a little slower towards 2. But you can see, if you look at the y values, what the slope is approaching. As I get closer and closer to 2, the slope is approaching 0.5. It looks like it's getting real close to 0.5. You with me? All right. So if you say the slope goes to 0.5, now we're supposed to, I think we're supposed to say, all right, verify that with calculus. Well, what is the slope at a point? What's the derivative of natural log? What point are we interested in? At 0.5 or at x of 2? 2. What is the derivative of log? 1 over x at 2. Hey, yeah. Oh my. We know the derivative should approach a half. And that's what the slope is approaching in our calculator. You with me? That's the point of the problem. Kind of just reminding you of the big 2 points approaching one idea. You cool? Okay, 22. 22 is, okay, this has a point.
Good morning, Dublin Jaguars. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all. Today, 7th hour, there will be debate club meeting in Mr. Wolf's room. Don't miss it. There will be only meeting and deciding who will be on the debate team that will be representing Dublin, as well as other important information. See you there. Mr. Perigo has picked up all the items left in the boys' locker room and put them in the box it found. After next week, they will be negotiated. Hey, students, two colleges will be visiting Dublin today. You will need a pass at 11 a.m. for Weltman Nazarene Wednesday, October 2nd. Bring your families and enjoy the festivities starting at 5 p.m. We will light the bonfire between 7 and 7:15 p.m. Life-size pictures have arrived. The pictures are from August 23rd and 26th.
Just about to have a
Please
problem.
stop by
Take
the
out a
office
broke
to
man.
pick up
You
your
ready?
pictures. Make your voice heard.
Okay.
Devlin's Diversity and GCA Club will host a Make Your Voice Heard open mic on the topic of gender inclusion and the LGBTQ community in Miss Young's room today during 7th hour. Sign up with Miss Young today and join us in E250. See you there. Floyd's mentoring will meet today in their assigned room. Check the mentoring bulletin board outside the cafeteria if you forgot where to go. See you there. Jack, your varsity cheer team is selling 3 styles of scrunchies for $4 or get all 3 for $10. They come in 2 styles of jack print and 1 green and white print on print. We are selling them during both lunches or message one of your DHS cheer team members or the DHS cheer meeting team on Instagram. They are selling very fast, so get yours now before Bingo Day, which is on Monday. Lots of sound is on display by the gym. Please stop by and claim your missing items. All items will be donated today. Senior high students. Seniors, be sure to get to counseling to verify the spelling of your name and your diploma. A quick signature is all that is needed. Attention all juniors and seniors. If you would like to take the AP Language English exam on May 13th, please come down to the counseling to receive the registration form. We do not offer the course
This
at
should
that
be
point.
81,
If you
yeah?
have enough students to sign up, we can offer the exam. The form needs to be turned in by September 30th along with $95 to the
Okay.
driver.
221
This Sunday is the biggest NACAC college fair in Colorado from 1 to 4 p.m. at the Denver Mart. Over 300 colleges and universities will be visiting with students. This is a great way to see universities who will not be visiting Denver. That's pre-registered. See posters around school or stop at counseling. Hey Jack, do you want to help save a life? Devlin is hosting a blood drive on October 1st. Donors must be at least 16 years old. Students ages 16 and 17 need to fill out a parental permission form. Make sure to eat before donating blood. Sign-up sheets and parental permission forms will be located at Mrs. Krasinski's office. Junior high students, it's homecoming next week and time to celebrate. The Devlin Junior High Boosters are hosting their fall social on Friday, October 4th from 2:30 to 4 p.m. in the cafeteria. Tickets are $5 and must be purchased during lunch on Thursday the 3rd or Friday the 4th. Fourth straight league win for Emily Belmonte and Sarah Hitchcock in their Green Mountain Gymnastics team. Solid performances from both girls claiming second and third on the varsity all-around. Sarah placed first on beam and vault, and Emily placed second on bars. Congrats, girls. Please support the Boys Tennis team and buy a drink from Boba Zone on Bellevue and Kipling today. Mention the team and they will donate 20% of the proceeds to our team. Go Jack! Hey Jack, it's time for your daily day of the day. Happy National Chocolate Milk Day.
Oh.
Don't forget about Big Coke Day on Monday. That's all your announcements. Have a great day.
Oops. Have a nice day. That should get you going. Have a great day. Good weekend. Have a nice day.
What?